Thanks for joining me in this room. I know Sebastian's in the other room, so we've got fierce competition. I'll be talking about growing a file system today. My name's Frank, and first I'm going to address, as was listed in the description, how we can serve files to over 100,000 users. Well, there are some ways you can do it. For instance, you can email the files. Might not be the most performant or the most ideal thing for a use case, but an alternative that you can definitely do is use a CDN. So if you really need to get files out there over HTTP to the people, and you don't want to have to be concerned about the delivery process, use a CDN. So that's how you serve files to 100,000 users. Thank you for your time. No, but seriously, you've got a lot of services out there that can easily do this for you. Who's here in the business of serving files over HTTP? Normally there is nobody. Apparently there are a few people here that run CDNs. What is that? Do you do CDNs? Don't do CDNs? Okay. Anyway, if this serving files is not your core business, maybe don't do it. Let somebody else do it for you, so you can focus on the stuff that's really important to your business case. So what this talk is really about is talking about file systems instead. We have to grow our application so that it bears the complexity or the structure to be able to grow file systems in it. So it's more like nurturing your file system rather than being in charge of delivering it yourself. So it's not just about storing files. So what is growing a file system about? It's about gaining understanding. What is a file system? What are we working with? It is creating structure in chaos, so organization, and it's about preparation, preparing your application for the future. It's going to be in a state, it's going to be used, so unlike your PHP code where you're actively growing your application code-wise, once your application is at a certain stage, files will be added by users, and you need to facilitate that growth. So who am I? I'm Frank. In German it's pretty much the same as in Dutch, so Frank is perfectly fine as well. I'm at Frank de Jonge on Twitter. As you know, I'm not German, I'm not English either. I'm Dutch. We're famous for tulips, failing soccer teams, apparently. So, I live there with my girlfriend, and when I'm not doing code, I'm behind a drum set playing punk rock music. But that's all nice and interesting for me, but how it relates to you, why I'm up here probably, is because I'm one of the guys behind the PHP League project. Anybody heard of the project before? Thank you. Okay. A few people, I think about maybe 20% here in the room. I hope that will change in the years to come. One of the projects under the PHP League is Filesystem, which is a file system abstraction layer. I created that and currently maintaining that. And while I was maintaining that, I got a lot of issues and questions from users. So I know quite a bit what the pain points are, and mostly they are with handling file system storage in your application as part of your domain logic. So that's why I'm here, basically, to share that knowledge. So first part is understanding what is a file system. It's important to know what we're working with. You do the same for databases. People research different kind of storage or database types. to see if they're the correct fit. You need to know things about file systems, and file systems are more concept than implementation. Like the file system itself is already like an abstraction over something else. So we're going to go back to the basics here. What is a file system? A file system provides structure and logic to control a storage area. Without a file system, it would just be on a disk a blob of data, and you wouldn't know where things start and where they end. So it would just be an endless stream of you don't know, and it would be impossible to do anything with that data. You wouldn't know if you wanted to delete a file. You'd first have to scan the entire disk basically and say, okay, I think it starts here and ends there, so I'm going to delete that part. That's not very useful, that's not user-friendly, that's not developer-friendly. So file systems were created in order to manage that. So it provides structure and control, but in what ways does it do that? It does that by creating concepts that we work with. So two of those concepts are files and directories. And you have ways to control it. So ways to interact. You need to delete a file, write to a file, or whatever. But what is structure? We'll look at the first part. Structure is really divided into types. That is files and directories. So if you look at files, they provide a sense of purpose, basically. If you look at these files, it's pretty easy to see which one is the profile picture. So you get a sense of the purpose of a certain file. The same case is for directories. I've got two directories here. One is user upload, the other is application cache. You don't have to be a rocket scientist to know what those directories are for. It's pretty apparent. But conceptually, it's really powerful that we have these tools so we can essentially namespace the files or the directories that we're working in. And so we have a sense of where we are. And then if we look at file system types, there are actually two types of file systems, generally. One is the nested file system, and this is just a piece of Filesystem. So we have a source directory, and we have an adapter with f2p.php in it. So we go into directories to see what's there, and that gives us a sense of scope. The other type of file system that we have, this is also, if you like, open up your Finder and you walk through directories, this is essentially what you're working with. People on Windows open some other type of program and basically experience the same thing. The other thing that we have is linear file systems. And in linear file system, things work a bit differently. So here what you can see is we still have like paths, but there is no nesting anymore. While the other was clearly nested, this is just a full path. And this is called a linear file system. Who here has worked with a linear file system before? Who here has worked with S3 before? Okay, somewhat more hands. Well, everybody who's worked with S3 before has worked with a linear file system. This is a linear file system. And it's really applicable for the use case of S3 because it's mostly used for applications. Applications address that. This is a reason, like human-like directories, you can go into a directory and you can see where you are. But computers really don't care. They can consume a lot more and make sense out of it still, while we just see a giant blob of paths that we have to scan through. We get confused, but a computer is much better at handling this. But it all boils down to, it creates the context in which we're viewing things. So it's all about scoping. But of course, we need to take control of our file system. And this is where the interactions come into play. So the common interface for dealing with files is a set of normal operations. So you write, you read, you update, you delete, you list files, and you inspect them. And what I mean with inspecting them, that's, for instance, getting the MIME type of a file, or seeing what the latest updated timestamp is of a file. So if we look then in PHP, how do we interact with the file system using just plain old PHP? Well, it turns out in some ways using PHP as is for that can be kind of awkward sometimes. For instance, if you want to list files, you have a lot of functions. You have the glob function, which takes some sort of like an expression. Then you have scandir. Who here has used scandir? Well, I never used scandir, but it's there. You can use it. You can use readdir, but it needs a handle, which you can create with opendir. Or you can use directory iterators, and those are really nice, but somewhat more complex. Here you can already see you need an array map function if you want to have plain PHP arrays backed with some metadata. So you need a sort of like normalizer. You need to convert the iterator to an array, and the iterator itself, you need to pass the directory location in it. Which one do you choose for which situation? Yeah, nobody, well, there are certain people who really know, but majority of the cases, people just go with what seems to work. But it gets worse than this, because what if you want to do recursive listing? Well, while we first had a glob, which was fairly easy, just one function and a relatively simple argument, now we come into this whole madness where we have to create a recursive iterator, which takes a recursive directory iterator, which takes a location, and you have to specify that it skips the dots. Also, the recursive iterator, you have to specify that you want yourself first, and then the rest of the children inside you, inside the directory. Fairly complex, I'd say, for just a simple operation. And this is just a listing operation, but there's more. There's also things like just writing files. Well, in vanilla PHP, it's relatively easy. We just use the file put contents function. We specify the location, and we specify the contents of the file. But what if we want to work with storage systems that are not local, and we want to use something like Dropbox or FTP, or we want to use Rackspace Cloud's file storage, then you get something like this. For instance, for AWS, you have to use the put object function. So now we're putting an object, not a file anymore. We have to give it some options, and one of the things that you need to take into account, like you can no longer just write a file, but you have to take into account that you need to specify the MIME type before you send it over, because if you don't, AWS will say it's an octet stream, and which is basically super generic MIME type, and when it's then downloaded or sent back to the client, it will have the wrong MIME type, so possibly your browser won't know what to do with it, and all of a sudden an image that would normally be displayed on your web, in your web browser will now be as published as a download instead. So you need to take that into account. Same goes for Dropbox. We have an upload file from string function, which takes a location, takes the contents, but now all of a sudden we have to know which write mode to specify. There are two write modes. There is add and overwrite, possibly also append. But for now, if we just want to write a file, we need to know whether the file exists on the file system already in order to specify the correct value here. So that's, again, a level of complexity added on top of a normal operation. Rackspace, same thing. We're uploading an object, not a file. And then we have this nice thing called FTP. It's not a nice thing because it's very difficult to get right. It's very easy to get wrong. Also, as you see here, FTP, the implementation in PHP, doesn't support strings. So what you need to do, if you just want to write a simple string, you need to create a temporary stream, a resource, and then you need to write the contents that you want to upload eventually to that stream. You have to use FTP fput in order to do that upload, close the stream, and then somewhere in between the FTP fput and the fclose, you need to catch the results and assert they're all true in order to know if the progress was handled nicely. This is basically too much overhead for just writing a string to an FTP server, in my book at least. So there are a couple of downsides here. There's no generic interface to these things. They're all different APIs. They have different method calls. Some don't even call it files anymore, but you're working with objects. And they all support different kinds of input. So on the one hand, you've got strings, and on the other hand, you've got streams. There are adapters or like file systems that either support one or the other. Also, we just looked at a method call now, but if you look at all the results from all these functions, they're all different. So none of the results are the same. So in our code, where we consume this code to be able to talk to the file system, we need to take into account what file system we've actually used and act on it accordingly. This has a couple of consequences. For instance, choosing a file system can create technical debt. What do I mean by this? If you're consuming the AWS SDK and you're uploading a file, that code that you've written in order to be able to talk with the SDK is aware of the implementation detail, which is the storage. So what happens if you want to change to Rackspace, for instance? If you have multiple places across your application where you handle file uploads, or you process files in any way, which is very common, then all of a sudden, in all of these places, you need to go in and change the implementation there. So this, in turn, can create vendor lock-in if you've got application code specific tailored to the AWS SDK, and you want to change to something else, but it's in so many places, it might be a week worth of work. And your manager might say, or you might say, well, is it really worth spending a week's worth of developer hours in order to change storage systems? It might not be worth your while. It also requires you to invest. I know back when I first started using the AWS SDK, a lot of new concepts were thrown at me. A lot of things I needed to research before I could actually be productive with that SDK. So it's required of you to invest. So, of course, after a lot of complaining, it would be kind of not so cool if I didn't have some sort of solution for this. So the solution that I propose is to use a file system abstraction, obviously. So what does a file system abstraction do? It bridges the gap between different file system implementation and normalizes the response. So if we, of course, as I mentioned before, as part of the PHP League, I've been working on Filesystem, which is one of those file system abstraction layers. And this package provides a common interface to file systems. So if we look at Filesystem, on top we've got the bootstrapping. So we have a local adapter. We instantiate it with the path of our root. And then we create a new file system which takes the adapter as the initial argument. And then you can operate on that file system quite normally, and also in a way that probably you expect. Things are really guessable in the API. So like, I want to write, well, the function write is there. I want to read something, the function read. It's all, you can pretty much guess the API. But now, what if we want to, we've got this in our application and we're doing everything locally, but now we want to move our assets to S3 instead. Well, okay, so something completely different. We use AWS S3. What you can see here is that all the basic operations are still the same, but the storage backend is completely different. We've now only got a different adapter. We've got an AWS S3 adapter. We pass that into the file system that we're operating on, and everything stays the same. This is the same for FTP as well. Who here has used FTP or has talked to FTP with PHP? Who likes it? No hands? Okay. I've never ever met somebody who liked working with FTP in this context or in any context. So imagine if that job that we're doing then with FTP was basically as easy as this. And this was actually my first use case for using Filesystem or creating Filesystem. I was working for a company and I needed to work with an FTP file system. We needed to get some XML data because we were super enterprisey. So I needed to connect over FTP, get the XML data, parse that and do some logic. But I'm a freelancer, so I like to work from my own office as well as from the clients. So I had some application code spiked out, and then I went back to the office and I tried to run the same thing, and it broke. What was the case? The FTP server had a IP whitelist. So that FTP server dictated that I would be at the client office and I couldn't move anywhere else. So what Filesystem enabled me as a person to do was recreate the file system that they had there, copy that while I was at that office, and then work with that while I was in a remote location. So in a way, this file system abstraction gave me some personal freedom even. But it's not just AWS and S3 and FTP or Dropbox. It's a lot more. We've got local, there are things to work with Azure. Even if you want to work with zip files, you can do that. There's a lot, and a lot of people are contributing these as well, or even owning repositories that do this stuff. And it's very well integrated. There is, of course, a Symfony 2 bundle. There is a, I don't know what plugins are called in Drupal. Is there a Drupal person in the house? Modules. There is a Drupal module. Laravel 4 has an integration. Laravel 5 ships with it by default. And for the other major things, there are integration packages as well. So what's great about it? You've got a normalized API, you've got normalized responses. It's a lower investment. You don't have to know everything about the SDK. Filesystem will actually normalize common or take care of common gotchas for you, like that MIME tag that you need to specify. Everything regarding that is pretty much taken care of. It's a lower investment. Oh, this number is actually wrong. I did this presentation not too long ago, and it was a 1.6 million downloads on packages then. But it's at 2.7 million now, so it's growing quite rapidly in terms of downloads. But one of the more nice things about it is that testing becomes really easy. You can use Filesystem to test your file system interaction. Who here tests all their file system interactions? Win? No, okay. No, I actually lost. I wish it was easy enough for everybody, but often it's just not so easy. You have to create like stub files and mutate those. But basically what you want to test is interaction between a file system, so it's assertions on function calls basically. But that's not really possible. So if you build on Filesystem, we can do something like this. We've got an author bio server, so whatever, which takes the file system interface, and when we need to get the biography, we say this file system read, and then we pass it the bio location. And testing this is super easy. I'm using Mockery. Well, Sebastian is not here, so he might not hate on me using Mockery instead of PHP unit internal mocking stuff. Anyway, everybody familiar with Mockery? Somebody not familiar with Mockery? Okay, basically Mockery is a tool that you can say, I want you to act like you're this, and you create some assertions on it and you set the expected response. So everything that's under the hood is ignored, and we just validate the interactions between systems now. So here you can see we create the author, we give it the mock, and we can just do a simple assertion to see what kind of response we're getting. So super easy file system interactions testing. Anybody who has done some file system testing outside of file system abstraction can tell you it's a pain to do without. That's probably the reason why nobody in this room was testing them in the first place. Excuse me. As a bonus, this really speeds up your test suite. Everybody hates it, like if you do a code change and you want to run the test suite and you have to wait 5 minutes, that's not acceptable. And this, if you have many file system interactions, this is what will happen. Because every time if you use the file system, you have to wait for the file system, and the file system is inherently slow. So if you do this, everything is in memory, so it is an instant speed boost for your tests, so you don't have to wait for them anymore. It also improves the stability of dependent code. A class should only have one reason to change. Changing file systems shouldn't be one of them. Most things that interact with file systems don't really care where exactly they're placed. They just want to write to a file system. The specific location of the file system should be a configuration detail. Filesystem enables classes to be totally unaware, so you can stupefy your classes basically. So it also opens up new possibilities. For instance, I've had a client and they needed to do very large uploads, like 15 gigabytes or whatever. Who here handles big files in their applications? How easy is it to handle big files in PHP? I see one thumbs down, one, and okay, so it's not easy. You have to really configure everything a lot tighter or a lot looser in other situations. Up limits of execution times. There is no progress, or there is now, but it's clunky for tracking upload progresses. So what you could do instead is use Dropbox for that upload. You just share a folder with your client, say upload it there. It will have the feedback from Dropbox. It will know when it's uploaded, and then your system in a background job can download the file from Dropbox. So you don't block user interaction that way, and also server-to-server communication is a lot quicker than client-to-server interaction. So uploading the file from the web server will go extremely fast compared to uploading it yourself as a client. So now we know what file systems are and how we don't like to interact with them, and we know what a file system abstraction is and how we use that and how it creates new possibilities. But there is a different side to this as well. and that is knowing your file system. So now you have some tools in order to simplify the process of doing this actually, but we need to take a step back and look at it from a more conceptual, domain-specific point of view. You need to know why you store files in order to know where to store files. A lot of times people organize their code really neatly. They have all their code tested, of course, in 100,000 ways. And then you go to the file system and it kind of looks like this. So like, yeah, this is not okay. By the way, this is a classic blink tag. I included that, hoping it would blink, and it wouldn't. So I added a CSS animation to put the behavior back so it now actually blinks. Anyway, what we need to do is treat our files with a little respect. Any music lovers in the house? They might know who that lady is. If not, moving on. What you can do is, and that's often what you don't see, is that you can formalize your naming strategy. Think of it as treating your directory structure like API endpoints. We're really cautious about the URLs that we expose. If we do REST, we have certain types of conventions. But then in file system stuff, we see, well, not so cleanly formatted paths there. So to compare the two, we have horrible examples like a generic user uploads folder, which has client 1233photo.jpg. And in the same thing, we have something totally unrelated, which is a post header for, I think, post number 493. What would be better if we have some sort of hierarchy in this approach. So we have a client directory and the client identifier there, and we have an avatar there. So it's already a lot cleaner. And if you look in one of those directories and see more files there, we can apply certain patterns to make this even a bit nicer. So we have the client, which has the header, but we want to have it in different formats. So here you see we have a header, but we also have a large header, a medium header, and a small header. If we distill this down into like a pattern, you could basically say that you can format them according to a couple of rules that you as a software developer can specify for certain use cases of files. So we have a directory which has an owner, so the owner identifier could be the directory name. And then we have a purpose of a file. What are we using the file for? And then if you have multiple variants, we can apply the same pattern and we say owner purpose underscore variant. And this would already be a nice formalized way of structuring those. As you saw in the first examples of file names, you saw client identifiers in there. I see this in many projects often, but it's a horrible idea to do that because it makes maintenance on your file system extremely difficult. Just think about, I need, client X has deleted his account. I want to delete all the files associated with client 123. If I have the client identifier in the file name, I need to perform some regex magic, possibly, to facilitate this process. That's not really nice. What you could do instead, use the other way, and then it would just be file system delete dir. And then all the files would be gone in one function call. So that's a lot easier cleanup, a lot nicer in terms of management. But how can we apply this? Well, we could look into a command handler kind of pattern where we have an upload handler, which as a constructor argument receives a file system, and it can handle a upload. And when we handle the upload, we can say, well, get the client identifier, get the purpose of what we're uploading it for, and this is a real generic upload handler, and then create the format that we've specified. So it will be client, and then the client ID, then the purpose, and then the original .jpeg, for instance. This would make sure it's handled in the same manner every time, and it's easy to spot in what format it will be. But you can also take this a step further, and you could say, I could also create a service that would provide this for me. So for instance, you could use a path formatter, which can have functions that will create paths for specific types. For example, we had the author before. We can say, well, the path formatter, and we have an author picture formatter there, which actually takes the one of our entities which is meaningful in our domain and creates the path for it. So now you can have a centralized location where you can do formatting for everything belonging to those entities, which is a quite powerful concept. Also another tip, always keep the originals. I see it often that people receive the file and they say, well, it's a bit too big. I will resize it to the header format that we're using on our website and store it as that. But storage is super cheap, and designs change over time. In a project that I've recently worked on, the design got a complete overhaul, but the system was already live for, I think, 5 years. So they had a lot of assets, and they were all cropped or resized to the size that they needed to have, and in multiple formats even. What ended up happening, they needed to migrate the entire file system and reformat all those files. This migration actually took 4 months. 4 months of 4 servers just bashing away new files into the new structure. If you've got your code up for the new application, it shouldn't be this hard in order to get to the new format. But it was also a different problem there. They had everything on the same storage unit. Big file systems are very difficult to move, so it's very smart to split them up. And you can split them up very easily at the beginning of the project based on a number of criteria. So basically what you need to do is identify the needs of your files. You can, if you have images, you might want to throw them on an S3 bucket and use CloudFront in order to get fast delivery. So basically what you need to do is separate your files by the needs. If you have movies or videos, you might want to put them on some sort of CDN which is good for streaming media, for instance. And Filesystem helps here. What Filesystem does is differentiate, basically cut the full path of a file in half. The red part is what you put in as a constructor argument for your file system, so this is configuration, and the rest is what's specific to your domain. So it maps to configuration and domain-specific stuff. What you can then do is, for each purpose, for each concern, you can create one file system. So we've got RSS feeds locally, we've got user videos also locally, and user photos also locally. At the beginning of our project, this is probably okay. But later on, our needs change. So it might be in the future that we want to use specialized storage system instead. So for RSS feeds, local was still okay. But for our user videos, we wanted to go to S3, to a specific bucket for that. For user photos, the same. And we can hook those buckets up to other services like CloudFront or a streaming service also by AWS. They have that, I think. So it's very easy then, if you have them split up from the get-go, to tailor to the needs that might arise at a later time. So a recently fired person just said, you know what, we need a different storage engine, so I'll just move all the assets from one storage engine to the other. This rarely goes right in the first go. Instead, it's easy to have isolated storage unit, so you can move one over at a time, see what the consequences are of that move, see how the new file system behaves, instead of just going like blindly to that new file system. And basically what you have to do then is every consequence that you encounter then, you'll have to do hotfixes for that, and it's going to be panic at the office. So isolated storage units are easier to move. They can tailor to specialized requirements, and they should be dealt with separately in your application code. This all boils down to always be prepared for the future. So I've got a couple of tips to help you be prepared for the future. The first one is wait. At the beginning of your project, whether it's databases or file systems, you don't know everything yet. Things might change later on, your needs might change later on. So you want to defer that decision as much as you can. I've got some more tips. It's really important to wait, and you should facilitate that you wait. To reiterate, past you and me, not just talking about you, this is for me as well, past me was stupid. I knew nothing about the application that I was developing. Current me does not know what's going to happen next week, and future me is probably super smart because he researched and dealt with a lot of stuff. So if I can take a decision and defer it to future me, chances are pretty big future me is going to make a lot better decision than I'm going to do right now. So waiting responsibly means use a file system abstraction so you can painlessly pivot from one file system to the other. You separate your files by concerns and do that early on. Treat the storage paths in your file system like API endpoints and don't put user credentials and file names. Always store the originals and use a CDN for high availability. Thank you for your time. Are there any questions?
Thanks for your talk. Do you know the library Gauffrate?
Yep.
What's the difference between Gauffrate and Filesystem?
The difference is in Filesystem I do a lot of polyfilling. I know that some cases are specific to certain types of storage implementations, like the MIME type stuff. I take that into account. I don't want every user to have to figure that out for you, while the package could provide that functionality out of the box, because it's the same every time. The same for stream support. That's really different in Gauffrate. Basically, you have this object that you operate on rather than a resource. And a resource is how we have streams in plain PHP. So having resources instead of that stream object is a lot easier to work with because it works a lot nicer with other libraries. So a lot of people integrate Filesystem with other open source packages. Like there's Glide, that's actually a package also from the league, and it uses Imagine to do file image manipulation, and because it's resource based, it's super easy to map one thing to the other and to have them interoperable, if you will. There are several other things like normalized responses. In some cases with Jonge you get different responses based on which file system implementation you choose. And like if you have the Liskov substitution principle, you should just be able to interchange them, and nothing in your code that actually uses it should change. And that's not always the case with Jonge. So Filesystem handles that a bit nicer.
Another question, is there a way to get the original response from the adapter?
No. There is mostly no need. Also, if you do need it, it's mostly a sign of a leaky abstraction. You might be better off addressing the SDK normally. Probably you're not using it as a file system then, but you're doing something really specific to S3 as the service. So, yeah.
But do you log the errors? So someone, if I have to debug something, I can see these errors in the log file?
There is no internal logging, but the S3 client, for example, has internal logging, so you can hook into that. There are different implementations of the file system interface. One is one that is event-based, so you can do like AOP-like things, but then event-based, like to facilitate point cuts or whatever.
You explained very nice the normalization between the different storage engines, but I wonder if we also normalize different file systems and different operating systems. For example, Windows file systems are case insensitive, and there are certain characters that are not allowed in Windows, but they are allowed on Linux, on Unix systems. So if you would swap the file system between Windows and Unix, its behavior would be different as well.
True, but that's a 0.00001 use case. So I don't tailor for that. I do tailor for Windows, but I expect people to be on Windows then. If you move the files, you get the behavior from that file system. Yeah, it's not big enough of a use case to account for.
Do you handle any, like, for example, symbolic links or like file system permissions, or an S3 you can add like header, like data to the files? Is there some abstraction there in your library?
Yeah, for permissions specifically, I made sure like mostly what's needed for permissions is it visible for a given user, yes or no. So there is this notion of visibility within Filesystem. So everything is either publicly visible or it's private. This is something that can be set as a standard for all file systems because there is no other more complex permission management that would be applicable for all file systems. So there is, but it's not called permissions, but it's visibility.
Then follow up, do you deal with tokens, or how do you give access if you want to give a limited access to a file, to S3 for instance?
That is again, that's a different concern than the file system itself. That's something CDN related. So what I try to do with Filesystem is tailor for the 99% use case. For all the other stuff, it's pretty easy to have something somewhere else deal with this. So Filesystem purely concerns itself with the file system interactions. Yeah, it is a common question though, but a lot of times this is something that should be dealt with in a different part of the domain anyway. So instead of making one mega super object, I try to keep it focused on just those tasks.
So basically we should stream through our application in these cases.
That's perfectly possible, yeah. That would also make the storage engine you less dependent on the storage engine because you're in control of the authentication instead of the other file.
Yeah.
You can do logging, stuff like that.
But of course, the best would be to upload the file loading to S3 via CDN and such. That's why the question comes up.
Yeah, yeah, true. But this again is a CDN related feature. This other, no, you can see me there. Okay. Well, thank you for your time.